Okay, we are moving on to part 3, and I didn't want to tell you the name of part 3 because it kind of gives it away. And so anyhow, we are on part 3. On the first part, we could factor out a greatest common factor, and then we'd be able to simplify further. On part 2, there wasn't a greatest common factor, so we made a table, the ACB chart, I call it. Now we're on to part 3. Same question applies. Can we make it simpler? Is there a number that goes into 3, 7, and 5? No. That leads me to the ACB chart. Factors of A and C that give you a sum of B. I would have 3 times -5, so -15. That give me a sum of +7. Okay, I will list my factors. The product is negative, so I know one term will be positive and one will be negative. So I will have -1 and 15. When I add those together, I get 14. 2 does not go in there. 3 times 5. The sum of -3 and 5 is 2. Oh, there isn't any more factors of 15, but I never reached a sum of 7. That means this is prime. And that is usually where I get students to cheer, like they're like, woohoo, it's over, we're done. You're right. What we know today, we cannot factor this. In Algebra 2, you will be able to factor this. Today, no. So that is why I didn't label part 3 as prime. When you get your work, you won't have sections like I did in the notes where it will tell you what to do. You're going to have to figure it out. So let's move on to the next one. Okay, we're going to approach it the same way. Can I make it simpler? Is there a number that goes into 3, 2, and 16? No. I will test my ACB chart. I need numbers that multiply to 48 but add to -2. Okay, notice here we have a positive factor, so that means we're either going to have a -1 and a -48. When I add those together, I get -49. 2 and -24. When I add those together, I get -26. -3, -16. When I add those together, I get -18. I have 4 and -12. When I add those together, I get -16. This one should actually be -19. Sorry, adding skills aren't on point. 5 does not go in there. 6 goes in there because 2 and 3 do. 6 times -8 would get me +48. If I add those together, I get -14. Ooh, I have run out of factors. I did not get to -2. So once again, this is prime. So I would like you to try the next one by yourself. I would like you to prove to me, just like I did above it, prove to me that one is prime. Please pause the video. Proving to me it is prime. Thank you for pausing the video. All right, really quick, I'm going to make my ACB chart. I did ask myself, can I make this simpler? There isn't a number that goes into 12, 5, and 2. My ACB chart, I would have -24 here with a sum of -5. So I would have 1 and -24 for a sum of -23. 2 and negative 12 for a sum of negative 10. 3 and negative 8. Oh, I tricked you. 3 and negative 8 do get me to negative 5. Just when you thought I was going to keep it simple. Okay. Standard form. Fill in what we know. Our original A term is 12x squared. Our C term is negative 2. How many of you did I trick? Kind of funny. You just never know what you're going to get. That's why I asked you to prove it to me. These two make my B term. Step 1, group. Step 2, greatest common factor, 3x there, leaving me with 4x plus 1. Notice here my signs are completely opposite. I'm excited to get the highlighter out. So I would need to take out a negative, and 2 is my greatest common factor, leaving me with a set of identicals. So, woohoo, woohoo. I will group my greatest common factors together. I will group one set of my identicals together, not forgetting to highlight in celebration. Hope I didn't trick you. I hope you ran it through the chart. Practice makes perfect.